Hi everyone, I'm back as a moderator this time, and I'm very happy to introduce our concluding talk together with our colleagues at EPAM, with Elene Botchoradze and Peter Abel. They are our colleagues working as software engineers at EPAM Systems, and we are going to talk about blockchain development. And we will discuss such topics like the learning path and the roadmap in blockchain development, and discuss about Rust and Solidity and how they can manage our everyday life, and what is already built on blockchain and maybe on similar platforms, and much more. So I'm not going to take too much time for the intro, and would like to pass the microphone to you, Peter. Hi.
Hi, Alec. Thank you. Thank you, everyone, for being here. Before we start, if I start to violently cough, it means that the medication I just took, the effect of it is waning. So sorry for that one. But then let's jump in and start our presentation. As you can see, we have here a very ambiguous title, blockchain development. So first, I would like to define what this whole presentation about and who is it for. We are going to talk about how to make that sweet Lambo money only the slow way. As you might imagine, in the last few months, basically this year, the only two ways to make money with cryptos is either to short the market or being in blockchain development. I'm not going to tell you about how to trade. I am fairly confident that you are perfectly capable losing your money on your own, but I think I can talk about blockchain development and how to start working in this path. Basically, we are going to deep dive into technical topics, talk about the basics of blockchain, even see some code samples, code snippets. So if you want to hear about how to trade NFTs and make money of it, then unfortunately, this presentation is not for you, but hope that everyone else who wants to learn about the actual programming part and development part of blockchain, you're very welcome to stay. But first, we should discuss what is a blockchain. As you can see, we have here the so-called blocks. But what are the blocks? Blocks are nothing else than virtual representation of data, objects, basically virtual objects. But why are we calling it a blockchain? So let's look at this example, this visual representation of a blockchain. As you can see, we have a genesis block at the beginning of this chain. This is the first block in our chain, which is a little bit different than the other one. Please see that we have three different variables at the bottom of this picture. One of these is called data. The data is nothing else than the digital asset. It can be a picture, a music that is on the blockchain. It can be anything. But what I want you to really concentrate on is the previous hash and the hash itself. So in the case of a genesis block, we have no previous hash because that's our first block. But if you would look at the block 2, you can see the previous block pointing, the previous hash on the block 2 pointing to the hash of the genesis block. Therefore, as you might imagine, each block pointing to the previous block and the following as well. And this is how we are creating a chain of blocks. This is called a blockchain. But how does it look like in code, in real life? I think for engineers, it might be easier to understand if you would see a coding sample, actual coding sample of it. I am a Java engineer, so I created you this code sample in Java language, but it will be very similar in any other object-oriented or even other programming language as well. As you can see, we have the same kind of variables here. We have something a little bit different that you've seen previously. We have this nonce, which is a number only used once. We'll talk about it later. But basically, we just have the variables as we discussed previously. in a simple Pojo. We have to also calculate the block hash, and this is where things are getting interesting. Obviously, these hash values are the real interest to us in a blockchain. This is the thing that gives us security. These are the data that gives us identity to the blocks itself, and this is where the huge need of computational power comes from. In a simple Java implementation, you can see how we can calculate the block hash itself. And I want you to pay attention that in the calculation itself, we incorporate the previous hash, the previous block's hash. We have a timestamp there, and we also incorporating this nonce value. And basically, the only thing that we are doing after that, just calling a hash function. In this case, or in the case of the Bitcoin blockchain, it is the SHE-256 hashing function, but it can be any hashing function as well. And just returning the data. With that, we calculated the hash itself, but we haven't mined the block yet. In the lower part, you can see the implementation of how we can mine an actual block. Please see that we are basically incrementing this nonce value. And this is the part where I should talk about what does it mean. We have two concepts in the blockchain sphere. One of them is proof of work. The other one is proof of stake. What you've just seen was the implementation and the representation in code of the proof of work model. In the proof of work model, we use that nonce, number only used once, number to increment the computational complexity and to validate the block. This is how we incorporate basically security to the system. Because so far what we've seen are very easy to understand and not a secure system. But the genius of Satoshi Nakamoto comes in when we really understand this proof of work model and how it makes this whole chain secure, how we can validate transactions in this way, and how we can ensure the identity and the uniqueness of each object that we are creating on them. So this nonce value is something that we are adding to the hashing computation, and this is the value that we are solving for. So the next block has to come up with a hash that will correspond to the previous hash and this nonce value. And if it cannot calculate it properly, we are increasing this nonce value, and this is how we increasing the computational complexity of the whole system, basically implementing security in the system. You have to understand that each block, what we are mining, increases the computational power that needed to mine the next block. So this means that the chance of malicious attacks or the reward after a malicious attack decreases exponentially each block mined. Basically, an attacker have to spend much more energy and resources to attack the system then burst it to them, because if you just if you have the same amount of computational power, you can really just go ahead and mine the blocks in the proper way, and your reward will be much higher than to try and attack the system. But this, as I mentioned several times, requires a lot of energy. Basically, this is why we call Bitcoin is like gold, because we are spending electricity to mine these blocks. The other concept that is much more recent, and maybe you heard about it in recent days. We had Ethereum 2 merge that really propagate this whole idea of the proof of stake system. And this is fairly different from what we've seen and what I just talked about previously, because instead of relying on the computational complexity and the size of the network itself, in a proof of stake model, the validators, so the nodes that are validating which block will be accepted to the chain next, are nodes that has a stake, so-called stake in the whole system. In the case of Ethereum, it would mean that it's a node that has deposited a certain amount, probably a large amount of Ethereum. Therefore, we are fairly sure that this node has no interest in hurting the system by undermining the value of its own Ethereum, or any other token can be worked this way. This is not as safe as the proof of work model, but it requires much less energy. And also, in some of our cases that I'm going to talk about, I think this is a much more easier to understand and approachable way how we can implement blockchain. But then let's talk about what are the potential applications of blockchain and how can we really utilize this new technology. So maybe you heard about it in the last couple of days. There were some amazing presentation about how healthcare service providers are incorporating this technology, protecting client data, and how they basically give back the client the right to handle their data. Also, banking is a self-explanatory thing, since we have so many cryptocurrencies nowadays, smart contracts. The banking sector is really heavily relying on this new technology, since you can use the blockchain technology to build on tokens on it, cryptocurrencies, non-inflationary assets. But what I want to concentrate really is the cybersecurity aspect of this new technology. Since I am a backend engineer, this is what I am really interested in, and I think this is the part that we can most easily incorporate in our day-to-day work. So let's talk about why incorporating blockchain into our already existing authentication and authorization processes are a good idea. Cybercrime costs the global economy an estimated $445 billion per year. That's a number that really makes me think that maybe I should have gone and become a black hat hacker, not an engineer. But let's really talk about how we can fend off these kinds of attacks, and what we can use, how we can use crypto to do so. So anyways, the current security protocols simply cannot keep up with the steady stream of malicious attacks. And a distributed ledger, like a blockchain, can be a really good place to start with securing our very valuable data. So I haven't mentioned it yet, but the whole concept behind a blockchain is not just that we have these secure computational processes, but also this is distributed across the network. And every participant in the network can see what's happening across the board. Therefore, it is very transparent. As you can imagine, this transparency comes very handy when we are talking about authentication and authorization, in a way that these are the parts that we can really concentrate on securing our applications. The practice of managing identities and discipline is a discipline of its own, and it is the heart of any identification management and identity access management. What I am talking about here is usually what, and probably that you are most accustomed to, that you have some kind of authorization and authentication in your already existing backend application. Usually, you are using some kind of encryption, maybe some kind of token to achieve this result. But the data, where this token coming from, the identity of the actors coming from centralized storage. It can be AWS or Azure centralized storage, but it is centralized. Therefore, it is a good point of attackers to exploit and get all of the data that needs them to violate their systems. In a distributed ledger, especially in a bigger system, we can really segment this data into different parts. So even an attacker pulls off a successful exploit on our system, it only compromises so much of our data. And as you can imagine, especially in an enterprise system, then we are designing to not just users, but really operators, many operators. If you distribute this data properly, that is a foolproof system, basically, that is almost indestructible. Now, I want to talk about what kind of options we have to build this kind of solutions, what kind of ledger types we can utilize. First, we can talk about the public ledgers. A public ledger is something that is like Bitcoin itself is a public ledger. It is a blockchain that is publicly available to everyone. The actors in the network are all over the world. Therefore, the security of the system is divided so much, and it corresponds to the size of the network as well. I don't want to burden you with the mathematics of it, even though it would be maybe useful. But the Bitcoin network is so huge that it's almost indestructible as far as we have active nodes, so-called miners in this ledger. But we have another option, which is called a private ledger. Why would you go in this way? In a case of an enterprise, like a bank, for instance, Morgan Stanley, recently implemented this kind of security system, which is basically they just created their own blockchain, and instead of giving it to the public, they pulled up their own servers, their own nodes. It is still distributed, but obviously the whole blockchain is under one management. And this is, I would say the best solution for a authorization system or in cybersecurity standpoint, because you can really solve the distribution of the data without the concern whether there will be enough motivation to run this whole network and spend the energy on it. Lastly, there is a so-called consortium, which is a mixed approach between private and public. It means that basically we have several private actors. This could be a very good solution for document management, for instance. If you have clients that you need to share documents and data with, and you are really relying on the validity and the integrity of that data, this is a very good solution to create a blockchain, share the access with the two parties. Therefore, you have shared accessibility and responsibility. Also, it is very similar. It can be very similar to a case when you have a healthcare provider and one of their clients. Basically, this is how you would interact with health data and such. Also, blockchain can be used to replace existing protocols like SSL-based protocols. This is fairly recent, but I'm very excited about this whole approach. basically you can really secure in a protocol level your system. All right then, but let's talk about how you can incorporate this technology, these amazing opportunities into your existing Java backend model. The first technology I'd like to mention is Web3j. Maybe you've heard about it yesterday. This is a Java-based technology, which is give you access to several different blockchains, fairly easy to use. I would say very good licensing. This is a good starting point if you want to go and use an open ledger, public ledger, and build your solution on that one. Secondly, we have Open Liberty. This is the solution from IBM. I would really highly recommend it. Even though IBM manages the blockchain itself, what I've seen so far and what I've tried, this is a very good solution, go-to solution if you want a secure blockchain that is managed by a trusted third party. It defeats the purpose a bit of the whole distributed system since you have a third party, but still it can be utilized very well, especially I would say for smaller startups and such. It's a good option. Bitcoin J is a library to use if you want to base your system on the Bitcoin network. I'm not going to go into detail in this. If you're enterprise, you probably don't want to go this way, but if you want to keep your data secure as possible and into the hands of the public, this is a go-to solution. And lastly, One Cosmos is a security-based blockchain, especially designed to authorization and authentication that I just talked about. So that would be my go-to solution if I would only want to use this technology just for these purposes. You still have the opportunity to implement a blockchain yourself, run your nodes, and do every bit of the work by yourself. And in the case of a big corporation, that may be the best option since you have all the autonomy and you don't have to rely on anyone or anything, I would say. Even though, as you can see, you can implement blockchain with Java, Java is not the most popular language for blockchain development. Some languages like Solidity designed to interact with certain blockchains like Ethereum. But you will hear about these languages from my amazing colleague, Elene. With that, I would like to pass the word to Elene. Please take over the presentation.
Hello, thanks for presenting me. I'm glad to be here. So in this session, I think you can move on to the next slide. So in this session, we will talk about what's the main responsibilities for a blockchain developer, how to become one of the blockchain developer and why, except Lambo, and how can EPAM help you to improve yourself in Bitcoin blockchain, sorry. So blockchain being the revolutionary technology has obviously opened many new opportunities for us and mostly for tech enthusiasts. But even with these fantastic opportunities, we don't know how to become one of them. So we will break some rumors here. We will talk about roadmaps and etc. So there are two types of blockchain developers. One is core blockchain developer and software blockchain developer. The core blockchain developer mostly works on architecture, responsible for delivering protocols and mostly systems, the design of consequences and other high-level decisions that are related to the blockchain. But blockchain software developers, on the other hand, use that architecture protocols designed by core developers and build decentralized applications to run on blockchain. So they are more responsible for front-end and back-end development and designing. So why should we become one of them? as Peter already mentioned about Lambo, you can boost your income really well. So we are forward and looking forward to get Porsche or Lamborghini. So also you can, as we know, Web3 right now is really important and popular because it is decentralized and so blockchain gives us opportunity to use its core for that. So if you want to become blockchain developer, you are looking forward for the future and you will be the future man. According to the Glassdoor, you see right now here, the average annual salary for a blockchain developer in US is over 100,000 USD. So doesn't matter where you live or where you sit, it's a comfortably right choice, I think. And as you can see, demand for the engineers is really high. As Peter also mentioned about the security engineering, it's also high demand role, but I think it's 5 times more demand for profession. So many companies and industries are decentralized right now and using DeFi mostly. They are now either changing their tech stack or adding new tech layer to their tech stack. So it's a really right decision to go in blockchain right now. It's so understaffed, which gives us opportunity to earn really good income. Yeah, but that's an insight to what blockchain developers will make and also just how demand it is. So right now we have to move on how to become one of them. First of all, I want to break the rumor that you need the degree. I'm saying this because I saw many articles about you should get a degree or study at college or in university, which is not true, I think, because it is skill and you are judged by your skill set. So first of all, you should try to learn what a Bitcoin blockchain is, how it works under the hood, so the basics of it. For this, I would suggest you to read Mastering Ethereum. Also, there are numerous YouTube videos you can watch about blockchain. Now it's really popular right now. Also, we have to learn some coding, which we will talk in following slides more about languages. Also, smart contracts are really popular right now. And that's all. I think you should keep improving and improving. These are top programming languages for blockchain development that it's vital to learn. We'll start with C++, which is really popular right now, as you know it. It's also used in blockchain technology. It's popular for Bitcoin also, which is a cryptocurrency and first ever implementation of blockchain, which was originally written in C++. And I think if you know C++, you can easily move on here because it has some multiple capabilities such as move semantics, primitive control over the memory, advanced multi-threading, and other features. Also, Solidity, which is one of my favorite. For example, it's one of the fast growing blockchain programming languages and was created by Ethereum and for smart contracts. I think we don't have a really good stable version right now, but if this version, it still works fine. We have also the code snippet. For this one, you can see this is very similar to the Java or JavaScript developers. So if you are a web developer and want to go to the blockchain and become one of them, I think Solidity would be right choice. As you can see here, there are some normal functions which return like IDs and have like just adopters, which is an array or something like that. And as you can see, it's so similar and human language, and you can understand very easily. So I think it would be great to learn Solidity. Also Python, which is really simple, as you know, you don't have to write so many code for this one. And it's a right approach in blockchain. So you don't need to type a lot of stuff here. Rust is second my favorite language. It became so popular right now. We have so many good programs written on it, like Solana, Polka. These companies and cryptos made some Rust more popular and popular. By the way, it's also really understaffed rather than other languages, because from my experience, this one is hard rather than Solidity or other languages. So this one is understaffed. So keep in mind that understaffed always works fine. So Rust is also good choices. These are languages I chose, but there are also other programming languages you can go with. These were my favorites. Right now, I will talk about how EPAM and blockchain work. So we have a competency center, which was established in 2016. And we have like so many international projects, products already delivered, and EPAM experts. How can EPAM experts help you to develop? That's kind of a good question, because you can like find any person in EPAM and maybe ask them for mentoring, or to give you a job opportunity, or to give you some roadmap, and there won't be anyone that you can't find. So I think that's a gift from EPAM to have an expert in this tech stack. Also, we have a monthly blockchain practices, which is in the next slide. So what is a monthly blockchain practices? Like, it's held monthly, as title says. We get to know new trends of blockchain, how EPAM developed in month by month, and what's our new job opportunities at EPAM. So we call new guys to like some of new people who want to become a blockchain developer. Also, learn epam.com gives us opportunity to get any tutorial, get any video. You can learn from there, and for free. So that's also a great opportunity for EPAMers. Also, KB Space, which is a knowledge space. For us, we get to know each other there. We share experience, or get some documentation, or maybe share some advice for each other. And the Telescope, which is my favorite. For example, from my experience, I searched there people who had some skill set in Solidity, and after that I found people who would like to mentor me and give me some job opportunities at EPAM. And so these are great opportunities that EPAM can give you, and you can improve anytime and anywhere as a software developer there. So thank you for your attention. Maybe Peter wants to add something.
Yes. If you are based in Switzerland and interested in blockchain development, the opportunities we have, then please contact me. I recently took over the Swiss blockchain community within EPAM, and there is a lot of new stuff coming by the end of October to our KB page. I really want to develop this community. So if you are interested in this whole topic, opportunities, maybe you want to work in blockchain or just want to understand this technology better, then please contact me. My name is a unique identifier. There is no Peter, Abel, Nagy other than me. So you can hit me up on Teams or in LinkedIn. Every question and suggestion is more than welcome. And thank you again. Thank you for being here, and thank you for your attention. This is the part for the Q&A.
Yes, thank you so much, guys, for your presentations. And we've got a couple of questions. The first one, and the most liked one, is from Sardor. Would you be able to elaborate on SSL replacements? Is that only related to SSL end-to-end encryption, when it fails to protect the metadata, and blockchain preserving the metadata using in communication, since the information is scattered across the distributed ledger.
I think the question basically was the answer itself, or maybe I misunderstood something. Let's see.
Yeah, it's pretty long, I would say. Maybe you can have a look at it in the chat. I have just sent it.
Give me a second.
Yes, and before you have a look at this question, let me ask Elena. We have a couple of more for you. I think they are addressed to you more. And the first one is, how can we use Python for blockchain development?
Yeah, so we don't have so many blockchain things that are written on Python, but I think these standards can be applied using any language. So, however, the only one I saw that was written fully in Python was a Cosmos. No, not fully, it was partly written, which is a decentralized network of an independent blockchains. But my guess is about speed, and because of Python, because it's a great scripting language and it's designed for easy user access and not high computer performance.
Okay, and where can we learn Solidity, but not in terms of an EPAM employee, but for everyone who is interested in learning it?
Come to EPAM. Don't think about anything else.
Okay, so I would suggest Crypto Zombies, which is a great opportunity to move from Java or another programming language, if you know something. So, but if you want to learn from scratch, I would rather say to learn web development at first and then learn Solidity itself. So there is so great like documentation. It's really easy to understand. So YouTube videos can help you to guide through this one.
Okay, thank you. And Peter, did you have a chance?
Yes, so I understood correctly. Basically, the question answered itself. Yes, exactly.
Okay.
I cannot add anything else to that.
Okay, yeah, that's a pretty massive text, and I think you can either confirm it or decline just it. And I think that was the last question from us and from the live chat. I really appreciate you coming here, and that was very productive presentations, and I hope that would be very useful for new people to come into this industry and into this domain. And of course, we will publish all the recordings just within a week. That was our last sessions of our Blockchain Community Day Conference 2022. And please don't leave this conference, because in a couple of minutes we'll be back with Alexander Pitkevich to make a sum up and say thank you words. And Peter, Elena, thank you so much for coming, and see you.
Thank you for having us.
Yeah, we are back in a couple of minutes.